This question reads, an air-conditioned room has a brick wall of 20 meters squared area and 50 cm thickness. The conditioned space is maintained at 20 degrees Celsius when the outside temperature is 45 degrees Celsius. The variation in the thermal conductivity with temperature is given as K equals to 0.95 plus 1.3 times 10 to the power minus 70 squared. Calculate the heat gain by the conditioned space through this wall. If you haven't watched our introductory video on temperature and steady state heat flow, I urge you to do so. Using Q equals to minus Ka dt over dx. Here Q denotes or represents the rate of heat transfer. Our A represents the area of heat flow normal to the direction of flow. Our K denotes the coefficient of thermal conductivity, while our dt over dx represents our temperature gradient. So from here we are going to have that Q dx is equal to minus Ka dt. But from the question, we're given that our K is equal to 0.95 plus 1.3 times 10 to the power of minus 7t squared. So from here we are going to substitute. Wherever we have K, we are going to substitute the value. We will apply the value of K here. Now we are going to integrate both sides. Recall, when we are dealing with integration, we say that integral of x to the power of n is the same thing as x to the power of n plus 1 all over n plus 1. So we'll be applying this rule when we are integrating. We are going to have q integral of 1 dx will be equal to negative a integral of 0.95 plus 1.3 times 10 to the power of minus 7t squared. By integrating both sides, we are going to have qx, applying our boundary conditions from the upper boundary to the lower boundary, will be equal to negative a 0.95 t upper boundary to lower boundary plus 1.3 times 10 to the power of minus 7. We are going to add 1 to 2 and that will become 3. T raised to the power of 3 over 3. So we can recall that our change in x, which is the same thing as x2 minus x1, was given to be 0.5 meters. So we are going to substitute. In place of x, we are going to put 0.5. So this is going to yield 0.5 q equal to minus 20 into 0.95. The difference between the temperatures, which is 20 minus 45 plus 1.3 times 10 to the power of minus 7, 20 raised to the power of 3. Recall we had t cubed here, minus 45 raised to the power of 3 divided by 3. So from here we are going to have 0.5 q will be equal to minus 20, which is our area, into 0.95. 20 minus 45 is negative 25 plus 1.3 times 10 to the power of minus 7 divided by 3. 20 raised to the power of 3 is 8,000 minus 911. From here we are going to have 0.5 q will be equal to negative 20 into 0.95 times minus 25 plus 1.3 times 10 to the power of minus 7 all over 3. 8,000 minus 91,125 will yield negative 83,125. So we will look at how to possibly evaluate this as well as this. So from here we are going to have 0.5q, which is equal to minus 20 into 0.95 multiplied with negative 25 will yield minus 23.75 minus, if we evaluate everything here, we are going to have 0.0036. Recall, to make something subject of formula means to make that thing stand alone. How can we make our Q, which is the heat gain, subject of formula? I'm going to divide both sides by everything standing close to Q. So from here we have that our Q will be equal to minus 20 over 0.5 into minus 23.75 minus 0.0036. Moving forward, we will have that Q will be equal to minus 20 over 0.5, negative 23.75 minus 0.0036 is the same thing as negative 23.7536. Minus 20 divided by 0.5 will yield minus 40 into negative 23.7536. We are going to multiply these two values to get our heat gain. We are going to have our Q will be equal to 950 watts. So therefore, our heat gain is equal to 950 watts. In my next video, I'll be giving a lot of quizzes. Do well to like and subscribe to my channel.